Welcome and study with Tanzania Institute of Education.
When anions arrive at the anode, they get discharged by relinquishing the extra charge they carry. A monovalent anion will relinquish only one electron to the anode. A divalent anion will relinquish 2 electrons to the anode. A monovalent cation will accept 1 electron from the cathode, and a divalent cation will accept 2 electrons from the cathode. The aim of this experiment is to find out different products produced when different electrolytes are electrolyzed using different electrodes. In doing this experiment, the following precautions have to be taken. 1. Electrodes must be cleaned thoroughly using distilled water and dried before being reused. A 12-volt DC source is more preferable to 6-volt alternative. In doing this experiment, the following requirements are needed. Apparatus, U-tube, copper electrode, carbon electrode, beakers, 12-volt DC source, dropper, connecting wires, crocodile clip. Chemicals: sodium chloride, potassium iodide, copper sulphate, phenolphthalein indicator, distilled water. Retort stand with a clamp and sandpaper. Clean your apparatus, starting by cleaning the U-tube. You clean the U-tube, then you have to clean your electrode by wrapping your electrode with a sandpaper like this to remove any impurity, or if there are some oxide found on the electrode. You clean until it shines, indicating that all impurities mount the U-tube on the retort stand. Okay. After doing that, in this activity, because we have different electrolytes here, we can start by using copper sulphate solution. So you pour copper sulphate solution in the U-tube. Since in this experiment we are using different electrodes, we have copper electrode and carbon electrode, let's start by using carbon electrode. Dip electrodes in the U-tube containing copper sulphate solution. Observe what is happening at the carbon electrodes. The one which is connected at the positive pole of the terminal, and another electrode which have been connected to the negative terminal of the battery. The electrode connected to the positive terminal of the electric source is known as the anode. And the electrode, if you leave this experiment for some times, you can see the changes. electrolyzing copper sulfate using carbon electrodes. At the anode, we have sulfate ions and hydroxide ions. At the cathode, we have copper ions and the hydrogen ions. The reaction which is taking place at the cathode is oxidation, whereby hydroxide ions is oxidized to water molecules and the oxygen molecules with 4 electrons. At the cathode, reduction takes place, whereby copper ions is reduced to copper metal. As it is seen here, this carbon electrode, which was connected to the negative terminal of the battery, is a cathode, and reddish brown deposition found at this electrode is copper metal. At the positive pole of the battery, where carbon electrode was connected, is the anode. The bubbles which are observed here are oxygen gas. The aim of this experiment is to identify different products produced during electrolysis using different electrodes. Requirements: apparatus, U-tube, several beakers containing different electrolytes, dilute sulfuric acid, dropper, small beaker, DC source, connecting wires, crocodile clip, different electrodes. Here we have carbon electrodes and copper electrodes, wash bottle, sandpaper, and retort stand. Chemicals: potassium iodide, dilute sulfuric acid, copper sulfate, and sodium. Make sure that your clamp is well tightened in the retort stand. Take U-tube and mount in the retort stand. In mounting the U-tube in the retort stand, you have to adjust it slowly in order not to break the U-tube. Then we add copper sulfate solution in the U-tube. Take copper electrode, wrap with sandpaper to remove all impurities in the electrode. Connect the electrode to the crocodile clip. Insert the copper electrode in the electrolyte. In doing so, look at your electrodes before you dip in the solution, and then observe what is taking place to the 2 electrodes. In dipping the electrodes, make sure that crocodile clip does not touch the solution. Wait for some time to observe the changes. The products during electrolysis of copper sulfate using copper electrodes are as follows. Ions present from copper sulfate are copper ions and the sulfate ions. From water, hydrogen ions and hydroxide ions. Hydroxide ions and sulfate ions move to the anode. Hydrogen ion and copper ions move at the cathode. The reactions which takes place at the anode is oxidation. In this reaction, copper electrodes corrode by a process of oxidation. Copper metal loses 2 electrons to become copper ions. At the cathode, copper metal is deposited to the cathode electrode by a process of reduction, whereby copper 2 ions gain 2 electrons to become copper metal. Observe the electrodes. This electrode, which have been connected with white connecting wire, is connected at negative pole of the battery. This electrode is a cathode. This electrode connected with the red connecting wire is connected at the positive pole of the battery. This electrode is a anode. Let us see the results at the 2 electrodes. At the anode, copper corrodes. At the cathode, copper electrodes look deep reddish brown, indicating that copper metal deposited at these electrodes. Now you can compare the result of electrolyzing copper 2 sulfate using different electrodes. The result of using carbon electrodes and the results of using copper electrodes. These are among of the factors which determine discharge of ions using different electrodes. Requirements: apparatus, U-tube, dropper, small beaker, 250 ml beaker, DC source, connecting wires, crocodile clip, carbon electrodes, and sandpaper. Chemicals: phenolphthalein indicator and potassium iodide. Procedure: mount the U-tube to the retort stand. Slowly, don't break the U-tube. Pour potassium iodide to the U-tube. Connect. First of all, wrap the electrode with sandpaper to clean them. And wash with distilled water. Dry the electrodes. Connect the electrodes to the crocodile clip. Insert the electrodes to the U-tube. and observe what happens at the electrodes. In electrolysis of potassium iodide using carbon electrodes, ions present from potassium iodide, we have potassium ions and iodide ions. From water, we have hydrogen ions and hydroxide ions. At the anode, iodide ions and hydroxide ions move to the anode. Here at the anode, iodide ions are discharged in preference to hydroxide ions. Iodide ions lose electrons and become iodine solid. At the cathode, ions present are hydrogen ions and potassium ions. Hydrogen ions are discharged in preference to potassium ions because hydrogen is below in the electrochemical series. Now, observe what happens at two electrodes. Here, carbon electrode was connected at the negative pole of the battery. So this carbon electrode is the cathode. Another carbon electrode connected at the positive terminal of the battery. So this carbon electrode is the anode. Observe what happens at these two electrodes, at the anode and at the cathode. At the cathode, there are bubbles which are found at the cathode, and at the anode, there is brown color which is seen here. At the anode, iodide is discharged to form iodine solid. The brown color which you see at the anode is the iodine solid. At the cathode, we say that hydrogen is reduced to form hydrogen gas. The bubbles seen at the cathode are hydrogen gas. So because hydrogen gas evolved here, and the hydrogen gas will escape. So let's observe what remains at this solution. We add phenolphthalein indicator to this cathode negative electrode. And also at the positive electrode. Observe the difference between the two electrodes. As you can see in these different electrodes, there is different colors. Here at the anode, there is a brown color showing that there is production of iodine solid. The iodine solid is responsible for the brown color. Here at the cathode, the solution changes pink, and you see there are bubbles at the cathode. The solution at the cathode changes color to pink. This is due to the presence of hydroxide ions present at the cathode and the hydrogen gas being evolved. In conclusion, from this experiment, is that the solution become brown at the anode, indicating that potassium iodide, which was our electrolyte, have been ionizing, producing iodine and potassium ions. That's why you see the brown color indicating that there is iodine. And potassium iodide, because it is colorless, also present in the solution. At the cathode, we observe purple color or red color and bubbles, indicating that hydrogen have been evolved and hydroxide ions remains in the solution. As a result, potassium and hydroxide ions are the one which remains in the solution, and this one can be proved by observing the color of the solution, indicating that the solution is basic.